Good afternoon, all.
Afternoon.
It's a great privilege to introduce our today's session speaker, Professor C Shivaprakash from IIC Bangalore. So he belongs to Department of Instrumentation Engineering of IIC Bangalore. His field of interest are electronic instrumentation, analytical instrumentation, embedded systems and development of high pressure DTA and its applications, cryocooler based cryosorption pumps, conducting polymers and OLEDs. So he was born on 4th June 1955. He took his BSc in 1976 and MSc in 1978, degrees from Mysore University. He passed his MSc examination with first rank and got 5 gold medals. He got his PhD degree in 1982 from Mysore University. He is a recipient of Young Scientist Award of Karnataka Association for Advancement of Science in 1983. Over the last 42 years of research career, he contributed substantially by publishing and presenting over 170 papers in reputed international and national journals and conferences. He has completed many R&D and consultancy projects funded by DRDO, ISRO, DST, UGC, and CSIR. He delivered many keynote and invited talks at the international and national conferences. He is a fellow and member of several professional bodies, including CA membership of IEEE, Fellow of Institution of Electronics and Telecommunication Engineers, Fellow of Institution of Engineers and Technology, Fellow of Instrumentation Society of India. He is a reviewer of many international and national scientific journals, member of Joint Review Mission of World Bank, TEQAP projects, mentor and performance auditor of TEQAP funded institutions. Currently, he serves as a chairman in committees of MHRD, AICTE, NBA, NAC, and UGC, New Delhi. He is a member of selection committees of many NITs and universities. He has been serving as a chairman of governing councils, senate, and academic councils of universities and institutions. On behalf of Mechanical Department and VELAMMAL Institute of Technology, we welcome you all, sir.
Thank you. Thank you.
Thank you, sir. Thank you, sir.
Thank you, Professor.
Yeah, yes, sir.
Okay.
Fine.
Very good afternoon and belated Happy New Year. Happy COVID-free New Year, let us say. We have had enough last 9 months.
Thank you, sir.
Let's, I'm a fan of, cricketer. I like cricket. I played cricket. I enjoy cricket. I see only T20, one-day match, and test match. As all of you know, test matches are of 2 innings. But I'm very happy that VELAMMAL Institute of Technology, they've invented one more cricket called 3 innings. This is the 3rd innings. November, they had 1 first innings, unbeaten in cricket terms, not out. December, they had 1. And now in January, they have the 3rd innings. I hope the cricket board, International Cricket Board, follows VELAMMAL Institute of Technology model. Very good. I mean, I'm very happy that they have sustained. 3 times doing over 3 months is a remarkable job done by Department of Mechanical Engineering under the leadership of Dr. Kaliyappan. And my first RT congratulations to all of them for successfully completed 2 innings and the 3rd innings day number 1. So it goes on, and I thank VELAMMAL Institute of Technology management, principal, deans, HODs, faculty members, Dr. Kaliyappan, of course. Dr. Basim is there, always with me. He keeps messaging me, and he has helped me a lot. So I learned a lot good practices from VELAMMAL Institute of Technology. So I hope that some of the participants who are there today may be new. If someone is there, it's all right. For them also, there will be a refresher thing. I thought
all the professors new only, Professor. All the
That's
participants
good.
new only. Yes.
Okay, that's good.
Yes.
So
Thank you.
then,
Thank you.
thank you, Dr. Kali. So I thought I can talk to all of you today, this afternoon, on challenges in good learning and assessment. In, of course, especially in technical education, post-COVID. You know that last 10 months we are going through, things have changed. So much change has taken place in the country. Last 10 to 12 years, all of us, most of us have been following the outcome-based education. Still, we are learning. We will continue to learn because, as all of you know, it is a lifelong learning. And you are all very familiar, familiar with national education policy which has come last year. So I would call it outcome-based education and national education policy. They are the two phases of the same coin. So OB is very, very important in achieving the national education policy, very, very important. At least definitely I'm going to speak to my friends at VELAMMAL one day about national education policy. I hope I'll get an opportunity. So today, coming back to today's topic, I always, want to say all of you are teachers. We all belong to teaching fraternity. As a teacher, the primary assignment to all of us is teaching. Teacher is a noble profession. All of you know, everyone in the world or country are produced by teachers only. Let them be a doctor, let them be a lawyer, let them be anybody. Everyone is nurtured by the teachers. So teaching is so noble. And today a little research is also expected from teachers. So I'm sure that every one of you have been engaged. And more importantly, post-COVID, mentoring has become more, taxing, of course. At the same time, you should enjoy because conventional mentoring has gone. Meeting them physically, how are you? Even if they don't meet, you used to take them as all right, there are no issues. But today, you know that students are there wherever they are staying. They don't have books, they don't have anything with them, but somehow they manage with mobile or some gadgets online teaching. So I hope that it will stop sometime and then we get back to our normal teaching methods. So mentoring, therefore, please keep talking to your students. That is very, very important. Give them enough confidence that things will come back, be ready. Ethics is very important. Without ethics, integrity and ethics, it is almost is very difficult to do things as a teacher. So the little story that I remember is, all of you know Sir C.V. Raman. He was the first IISc Indian director in 1933. He was the first Nobel laureate in physics, whole Asia first Nobel laureate in physics. So he, after Indian Institute of Science, he started another institute called Raman Research Institute. So he wanted to take some 3 research assistants, called for the application. Of course, lot of application, thousands shortlisted. Finally, on the interview day, 5 people are selected. So Sir C.V. Raman himself took interview for all the 5 people, and he was looking for 3 candidates, and he selected the 3. At the end of the day, he was going out of Raman Research Institute, and he saw a boy who attended the interview was walking near the gate very dejectedly. He stopped his car and asked him, "Why you are so dejected? Is it because you did not get selected in the interview?" The boy says, "No, sir. I was given a small travel grant for attending the interview, and about 15 paisa more was given by your office assistant. I went there to return the money to him, but he was not there. I don't know how to return that money." Then Sir C.V. Raman said, "Are you in Bangalore tomorrow? If you can come and meet me tomorrow, we will resolve." Who doesn't like to meet Sir C.V. Raman? So he goes there he calls that person and settles the account. And Sir C.V. Raman says, yes, you have failed in the physics interview, but you have passed in the honesty. I'm going to create 4th position. Are you interested to join? He got excited. He said, certainly I will join from tomorrow. He joins, he works with him, later does his work, goes to America, and finally he became a Nobel laureate, who is none other than our Professor S. Chandrasekhar, astrophysicist, who divided all the stars into 3 groups, big star, medium star, and so on. So the moral of the story is, if you are honest, a reward will come one day. So keep doing your work. So, but for his honesty, Chandrasekhar would not have joined Sir C.V. Raman. So therefore, as a teacher, we have to be, we treat our student and friends. Teacher is a philosopher and teacher is a guide. So that's what we all have to inculcate. According to me, a teacher should have 3 important qualities. 1, humor. 2, humility. 3, humanism. Even our Mahatma Gandhi once said long ago, but for my humor, I would have got suicide long ago. So therefore, keep smiling and make others smile. Humility, is about giving credit. I remember one of the chemists, Lipig, wanted to invent iodine and he could not succeed. Before him, one more person is invented and he gave all the credit to him. Normally people say, oh, I invented, he got the name. That he did not do. So therefore, please, as a teacher, all of us should have humility. Humanism, not necessarily monetarily we should help, intellectually, whatever we can do to our students, we should be doing. As a teacher, the next thing that I like every one of you to benchmark. We have to, this is what I want to do this month, this year, next year, this is what my, so individually, department wise, and institute wise, we have to benchmark. So therefore, in the post-COVID, we all have to think differently. One more little story I will tell before I start my talk today. The story is about think differently. The VIT hypothetical story invited 5 greatest scientists in the world: Aristotle, Newton, Einstein, Heisenberg, and Pauli. They were all invited at Chennai. Conference was over. They were all staying in a hotel. In the evening before dinner, they had time. They were all strolling. And one of the journalists caught them. And journalists, always peculiar. He asked a very peculiar question. Surprisingly, he saw a chicken crossing the road. He asked Aristotle, why chicken is crossing the road? Aristotle said, that is the nature of the chicken. His research is all about understanding the nature. So he answered that way. Then came the turn of Newton. Newton said, if chicken is at rest, it will be at rest. If chicken is moving with velocity, then he started deriving F equal to ma. The third turn was our great Einstein. Einstein said, I don't know whether chicken has crossed the road or road crossed beneath the chicken, depends on frame of reference. Fixed frame, moving frame, theory of relativity. So the beauty of the story is the question asked by the journalist is same, but the answer each one is giving is different. Fourthly, the great quantum physicist Heisenberg turn came. Heisenberg said, I don't know. Chicken was moving with a very high velocity. I could not measure accurately. Uncertainty principle. No 2 parameters can be measured accurately. Lastly, Pauli, he said, no, chicken has not crossed the road. There is already a chicken on the other side. All of us know little chemistry in the high school. No 2 electrons can occupy the same energy state. So this is how I think all of us should start thinking to implement meaningful outcome-based education. You enjoy, if you enjoy, naturally your students will enjoy. And thereby, let us all put our hand together to make the National Education Policy 2020 very meaningful. And things are moving very fast. Science is going very fast. Engineering is going very fast. Technologies are changing. We used to see in 70s only 2 cars, Ambassador and Fiat. Now today, so many automobile cars have come on road. So one small little again example, Einstein is a man. He was a great professor. He conducted the exam, invigilated, valuation is over. And after that, anyway, there is a tradition of giving the answer book to the student. Very transparent system. He gave, one of the students came back and said, sir, you have evaluated wrongly. The first question, there was 10 marks. I should get 10, but you gave me 0 marks. Einstein said, why? Sir, this question was repeated from last year question paper. My senior wrote this same answer. He got 10 out of 10. I took his notes and Makika Maki, ditto, I wrote it, you are giving me 0. Einstein said, yes, what you say is true. The question that I gave last year, question that I gave now, both are same. The answer which your senior wrote last time was the correct answer at that point of time. The science has changed and grown last 1 year, and the answer to the same question is different today. Therefore, I gave you 0. This is how things are moving today. So I talk, today my plan is following. I talk about what is science, engineering, technology for 1 minute, and about education another 1 or 2 minutes, and about industry another a minute, and come to what is good learning. Let us try and understand in terms of, in the context of outcome-based education. And today the virtual lab and online examinations are of the order of the day, how to cope up with that, and what are the technologies that are available. Possibly, I try to cover all this in the next, during my talk. All of you know scientists, all of you know engineer, and all of you know technologists. So I don't want to define who they are, but I want to say one thing, that a car that you see on the road will not come onto the road unless all the 3 of them are joined together. Scientists, they will understand the braking system, air conditioning, and so on. An engineer finally designs on the drawing board. Technologists will bring the car onto the road. So therefore, scientists are important, engineers are important, and the technologists also are important. Generally, people say scientists won't read and engineers won't write. But you, my dear student, teachers, you have to do both, reading and writing. COVID, always, we cursed so much that, but COVID also is an opportunity. A lot of things have changed. Environment has improved. The people, our health conditions have improved. So many good positives are also we can take. So therefore, I would say COVID is, we are creating an opportunity for victory in disaster. The one example that all of you are doing is, we did not stop teaching online or a blended mode, whatever the way we are continuing. And today, March 2020 is before March 20, I would call it as before Corona, and now we are in the Corona, which we used to call before Christ and after Christ. As I promised, I will spend a minute about education, what we are today, what was earlier. If you go back to education 1.0, the teacher-centric, mere lecturing, student need to memorize, standardized questions, and they get their marks. But later, the internet have changed the whole scenario. So then that was the education 2.0. But quickly, all of us realized that education should lead to knowledge. So therefore, knowledge producing education came into being. And very quickly, we all realized again, knowledge alone will not take us anywhere. We need knowledge. In engineering terms, we need KSA. All of you know, very familiar 3 characters in our outcome-based education. Knowledge, skill, attitude. So therefore, they are all important. And when we are parting the knowledge, skill, and attitude, all of us have to be innovative. Then only we'll be able to cope up with industry. The way the education has moved from 1.0 to 4.0, the industry also has moved from 1.0 to 4.0. If you go back in 18th century, in the Industry Revolution 1.0, mechanical productions of machines were powered either by water or steam, very small primitive ones. Later, in the beginning of the 20th century, the Revolution 2.0 took place where mass production took place. We started seeing even railway engines on the track. But the electronics and information technology has completely changed the industrial scenario that we call it as Industry 3.0, where there everything has become autonomous. You need not go to airport to book a ticket. People don't have to go to railway station to book a ticket. You can do wherever you are. If you have money, you don't have to go to bank. You go to one of the ATM and draw the money. So these are all possible because of electronics and information technology. And today we are in Industry 4.0, which is all based on cyber-physical system. Everything that you have can get connected with Internet of Things, IoT. So therefore, we have to prepare our graduates who can be a potential candidate for these Industry 4.0. So that is the reason why I showed you that we all have to adopt the faculty, all of us have to adopt Education 4.0. Thereby, our graduates will be ready for the industry. Just 1 minute only about this AICTE mandate, which all of you are very, very familiar. Induction program. You know, a student when they join, we give about 2-3 weeks of induction just to tell them what is engineering, why are you doing it, what are the ingredients, what is education, you know, what is your all other personality developments, you know, all the skills, managerial skill, technical skill. We try to expose them, you know, in the beginning. But faculties are also have to be exposed. Faculty also needs induction training program. I think AICTE has made, you know, a wonderful thing where today I think all of you who are listening to me is an induction program. You know, some of you are senior, but still you learn. Some of them are youngsters, you will really gain out of it. So therefore, these induction programs are very important. Revision of curriculum, you know, without going, you know, I already gave an example how fast things are moving. So therefore, we need to keep updating our curriculum. Training of the faculty, you know, I remember my days. In 1980, we used to take a train from Bangalore to Delhi 2 days and the train and then go and attend the winter school, summer school. Now today, there is no summer, winter. Any time in the year, anywhere, sitting anywhere, you are learning. That is all possible because of the AICTE platform that they have created. You know, mandatory internship. Internship, of course, people we say that students should go internship. I would even say every faculty should go to industry once a year, 5 days, to understand the industrial problem so that you can give some good project to student. You also can take up some good project to work on your doctoral work or even to guiding the students. Industry readiness is required, and examination reforms and online, you know, that things have already changed and is going to change further. Promoting innovation and startup, important. You know, in engineering is not just learning 40 course and go away. So therefore, I am sure VELAMMAL Institute of Technology, all the institutes where you are attending today, you in a small way you have an innovation or ideation center. So therefore, 5 P's are important. One is problem. 5P. Second P, problem, product, project, placement, patent, and placement. If you cannot get patent, at least go to placement, good placement. So therefore, students who are there in the second year, please let them choose some problem in the ideation center. So this problem, when they go to third year, will become a product, and fourth year they will do a project, and fifth year, you know, when they go out, some patent can come out or placement will happen. So these 5 should be one objective of our outcome-based education. So with all these ingredients will lead to accreditation. I just want to say one word at this point. National education policy affiliation system will go. Anna University will not be affiliating after 10 years. They have to become research university, and VELAMMAL Institute of Technology will become a degree giving university. IIT will become multi-educational research university. So in the country, after 10 years or 15 years, you see only 3 different types of universities. So therefore, you all, wherever you are, should aim to become the degree giving universities, for which, of course, accreditation is important. Later, always we prepare for MBA, SIR, and then committee goes, we sleep for 3 years and then come back. That is not accreditation. That is not outcome-based education. You have to practice. I always give an example. MBBS, you are not a doctor. BTech, you are not an engineer. Unless you practice, you will not become. So therefore, it should become a habit. So how do we start? A good start is important. In Olympics, 100-meter, let us say swimming, if you are delayed by 0.01 second, you don't get the medal. So therefore, a good start is extremely important even in the outcome-based education. So the quality of education, as all of you know, is very important, which I have told you. Even if you go back, Sir C.V. Raman said long ago about quality. I quote, students of today are being taught by teachers of yesterday with curriculum which is of day before yesterday. All of you agree that that's not possible in future. Why even that those days? So you have to change ourselves. We have to learn. So therefore, all of us have to be grateful to VELAMMAL Institute of Technology for having arranged this outcome-based education workshop. So learning is a primary thing that I thought I will dealt with. So learning is associated with another important factor called retention. I read for 1 hour, I don't get anything, is of no use. So I give a lecture for 1 hour. What is retained? One of the research says 5% is only retained. So student to catch them for 1 hour to read, retention in a class is not an easy task for a teacher. Very difficult task. So therefore, what research suggests is you have to supplement, augment with others. Reading. So once you hear a lecture, if you read, then your retention goes to 10%. Audiovisual definitely will make a big thing, and then your retention will go to 20%. That's how when you watch something, you will retain most of the thing. Larger instead of audio, video makes a lot of difference. Demonstration. This is where engineering experimental work, project, mini project, all these things that will enhance again to 30%. Group discussion, very important among the faculty, among the students, peers, that is will enhance to 50%. Practice by doing. So that is where engineering is not just if you go to elsewhere, they say engineering in Germany, engineers are trained. In India, engineers are informed. 40 different courses, 20 labs. That is not engineering. So therefore, practice, practice, and practice. Without practice, you will not become an engineer. Lastly, teaching others. Peer teaching, peer mentoring is important. This is how the learning pyramid says that retention is more and more. So coming back to the OBE, let me say before that, what an engineer is. According to me, an engineer should have 4 important qualities. What do we do in engineering? After all, engineering is for learning. Of course, without learning, nothing much we can do, but that's not the end of the road. Engineering is for doing, practice. That is where, more the practice, your curriculum should be designed in such a way that, 50-50, 50 theory, 50 practical. That is how a good engineering curriculum comes out. Third one, engineering is for living. After they graduate from VJIT or any other institute and VIT or somewhere, they should be proud, self-esteem. I am an alumni of this. And fourthly, engineering is for the society. Like all of you know, Sir Misheshwaraya. We all have to contribute back to society in some form or the other. So the basic philosophy of the outcome-based education, as all of you know by now, depends on you should have vision. I told you in the first slide, individually, as a department, as a program, as an institution, you should have a vision. In fact, India has a vision. ISRO has a vision. NASA has a vision. ISRO, 104 satellites were sent 2 years ago, of which 96 happened to be from USA. That is Great Indian Nuclear Club or Space Club, you can call it. So therefore, a vision is very important, and we all should strive to reach that vision. Vision is a very broad statement. Simple. I want to become the top 10 colleges in my state. That can be a vision. But how do you reach that? The way we reach is called mission. You have to write down, maybe by good teaching, my good entrepreneurship, good research, good post-graduation inputs, good whatever you think that the steps in which you can achieve that to become the number. So that is what we call it as a mission. So every institution, every program should have vision, mission, which all of you are very, very familiar with. But how does it happen? Vision is a broadest statement. Mission is broader. So therefore, the educational objectives are important. Program, civil, UG, UG of mechanical, UG, PG of the thermal, whatever you call, they are all, each one of them are called a program. A department can have many programs. Each program should have objective. This is what we call as PEOs, program educational objective. Again, objectives are broader, broadest, broader, broad. They are broad statement. Okay, so therefore, they are not measurable. So the way we measure them is through outcome. Outcomes are very specific statement. So program outcome. Each program, because in India we have agreed that there are 12 graduate attributes or program outcomes which NBA has initiated. And in addition to these 12, each program will have some specific objective. You may be good in entrepreneurship. You may be good in some aspect in your own institution, in your own subject domain, that you should write down. How you train your student, a project which is done in some area, that can be your program specific outcome. So these are all will be dealt in next 4 days in detail. Therefore, I am not going to the depth of it except to give you a very bird's eye view. CO, again, much more specific statement. C, course can be a theory, course can be a lab, course can be a seminar, course can be each course will have an outcome. So the course outcome will lead to the program specific and program outcome. In turn, they will lead to program educational objective and finally to mission and then mission. All of you are, since again, I will not spend more than 2-3 minutes because you are very, very familiar with these graduate attributes or program outcome, what we call. In some other country, they call student outcome. America, they call it as graduate attributes. So intentionally, I put the first 5 one as red. Any engineers, any graduates should have engineering knowledge. That is the reason why in the first year we teach them basic physics, basic chemistry, mathematics, of course, for 4 semester, and engineering drawings, a little bit of workshop, basic electronics, and so on. So therefore, as an engineer, we should have knowledge. I told you, without science, there is no engineering. Without science and engineering, there is no technology. So that is very important. The problem analysis. Don't you think the engineer should be able to analyze the problem? Unless you analyze, you will not become an engineer. And most importantly, every engineer should be able to design and develop the solution. Any problem, there should be a design. It could be a hardware design or a software design. And as an engineer, undergraduate, you should be able to investigate the complex problem. I am a computer science. I know C language. I know how to write a program to find out the area of the circle by C program. That will not give them job. They have to take more complex problems and then investigate. And modern tools. Everything cannot be in a given institution. Even IIT Madras cannot have everything. So therefore, one has to go to industry, one has to go to other institution. That's where your industrial interaction, industry and academia interaction will make them learn the modern tool. And everything cannot be taught in the class. So these modern tools, more they learn, more they are employable. So these 5 are like pillars of the any graduate attribute. In addition to these 5, which are cognitive in nature, where with 40 course and lab, etc., seminar, project, we also have to learn certain affirmative other domain about what is an engineer, what is society, what is environment, what is sustainable, what is technology, what is sustainable technology, renewable energy, whatever, ethics, which I have told you, a course need not be there. I can be as a teacher, go on time, come on time. That itself a student will follow. And another attribute they have to get is individual, how to work as an individual and teamwork. The project, 4 of them join together, and how they should know how to work individually by dividing the project into 4 parts and then integrate them, and then finally 100, each one 100 hours is equal to 400 man hours. So that is where the teamwork is shown. Communication skill, very, very important. That's where we give seminar, we ask them to present and so on. And project management and finance. As engineers, they need to know little economics, how to make, somebody claims is a low cost, it is economically, how do we do those little economics, finance and project management they should learn. I'm sure that every institution, they will have one course or half a course to teach them. And finally, lifelong learning. Whatever they learn in 4 years, next 40 years, they have to make a career out of it. So that is where the learning doesn't end at 4th year. It will go on and continue. So this learning, if I come back, it is like a triangle. It has got 3 components. One is instructional strategy. As a teacher, all of you should have some strategy to teach. And that's not the end. You need to have assessment tools. What are the good assessment tools? It's not just test, assignment, and quiz. You can always innovate your own assessment tools to find out whether they are learning. What for we do these strategies, instructional strategies and assessment to reach the outcome. Output is different, outcome is different. Placement is output. All 100 people getting a job is output, of which 10-20% they got this high salary, good core company. They are all employability. Civil, mechanical, electrical domain area they have gone, and then they are working is outcome. Employability is outcome. Therefore, in the country, the employability is only 25%. Our NIC, information, National Information Center data shows only 25%. That's where we all have to strive hard. So what is learning then? The learning is all about acquiring new knowledge, new behavior, new skill, new values, and new understanding. This is what in general sense we call learning. What is good learning? That takes place when learners are clear about what they should be able to do at the end of each unit, at the end of each lecture, at the end of each unit, at the end of semester, at the end of year. I can do this, having learned this. That is called outcome. So therefore, there should be perfect alignment among the instruction, assessment, and outcome, which I showed in my last slide as a triangle. What is outcome? If somebody asks you, an outcome is what learner will be able to do or perform as a result of some experience. If I learn and don't do anything, there's no outcome. So therefore, I will not again, since all of you are very familiar, Bloom is a great man who said the learning takes place in 3 domains. One is cognitive, second one is affective, and third one is psychomotor. And most of the engineering that we do is all come under what we call it as cognitive domain. And now what he said was the learning takes place in the cognitive domain in 6 different levels. What are they? Remember, understand, apply, analyze, evaluate, create. So you have to concepts, for instance, in engineering, you have to remember. For example, first law of thermodynamics. There is nothing short of memorizing. So that is what we call it as the elementary at the first Bloom level. So therefore, we need to remember. And it is not the end. If you remember, what do we do next? Explain these concepts. Explain these ideas. That happens in the second level of Bloom in the cognitive domain, which we call it as understand. So having remembered, I must understand. Now, having understood, you have to apply this to a new situation. Some people have understood, but how do we do? Apply these facts to the new situation. That is what constitutes the third level of Bloom cognitive domain. Having applied, as an engineer, we all have to break down the information synthesis they also can call, connect the ideas. This is called analysis. Analysis is very, very important. Then in the fifth stage, justify the standard decision. You develop something, you design something, software or hardware. How do you justify yours is better than others? They are all happens in the evaluation stage. And the last stage is creative. That is, produce a new or original work. It's called not possible in every course that we teach, every seminar that we give, every lab that we do. This all happens in a good final year project that we do. So therefore, many, all this, people have a oh, my course has got 5 units. When I go for accreditation, they say first unit is remember, second unit is understand, third unit is apply. That's not correct. First year when you are teaching, they are all on the lower or low bloom level. When you go to third year, fourth year, you can start apply, analyze, and evaluate. So therefore, the complexity, the teacher who teaches have to decide. So therefore, writing a good outcome is a very, very good exercise for people, in the beginning. Of course, learning should promote, when do we say the learning is promoted? The learners are engaged in a session with a real-time problem. So we should, at least in third and fourth year, the subject that we teach, core subject, the elective, we should give some case studies, examples, real-time examples. Then only they will understand. Existing, we say learning is promoted when existing knowledge is activated with the foundation. That should lead to new knowledge. New knowledge is demonstrated to the learner. And new knowledge is applied. And new knowledge is integrated. Then only we say that this learning is promoted. If only it ends only giving new information, that will not complete the. So in the triangle I showed you, the first corner is learning strategies. I am going to just give you few. You can keep on adding to this list. All of you know by now that engineering is about problem-based learning. You have to solve the problems. Otherwise just theory, that's why your tutorials and even exercise that you give, assignment you give, it should be based on the problem. Project-based, every semester you can have one mini project. Whatever they learn, they should do something, demonstrate. That is also another important, good strategy for the learning. Hands-on learning, teacher teaching 5 years, 6 years, he gains every time he teaches. It should be passed on to the student. He should not keep himself. That is what we call as experiential learning. By experience, going to industry or by listening to others, you learn many things. That should be part of one of the strategy. A good lecture that you hear can be adapted. How nicely he has placed it, how he nicely has organized. All these things should be part of your strategy of teaching. Internship. That's where I told even teachers should go once a year, 6 days, 5 days. So that you get an experience from industry, what they are doing, what are the industrial problems. Because there is a huge difference between field and the lab. It works in the lab, but not in the field. So those things, unless you go, unless you bring some problem, unless you take it up yourself, unless you give those problems to your student, you will not be able to. Flip classroom. Everything we cannot learn in 10 to 5. Everything you cannot learn in 1 week in OBE. You have to go back after this shutdown, school, and then you have to start practicing. So we can learn on Saturday, Sunday, evenings, wherever possible. It's called blended learning. Blended is you have to blend between online and offline. Now, because of COVID, class may not be able to. So therefore, lab they are not conducting. When they come back, you make them do experiments. So therefore, right now you make some blend. You blend it. Blended is between online and offline. So another important strategy that you can adopt is co-curricular experience. Tech fest that they conduct, the students will learn a lot, how to work in a team, how to manage, how to, event management, everything they learn. They learn how to present what they have done. Quiz. So many things happens in the co-curricular experience. It is very, very important, which we never give importance for assessment. If you look at the other 7 graduate attributes, communication skill. for instance, can be judged through these co-curricular experiences. You can assign some team to do something and then give an assignment. And another important strategy these days, everybody, even IIT Bombay, I've seen peer instruction. Students of third and fourth year who are good in teaching ability want to mentor, you can give 1 or 2 students of first year, second year, so that this is called peer. Today, you know that if parents tell them, they don't accept. If teachers tell, they pretend, they say yes, but they don't do. So therefore, peers is very important. What the strategy you can adopt is, you can make 4 students a group in a first year or second year BTech. Pair, this is called pairing. When they pair 4, one fast learner, one slow learner, 2 medium, they will share their idea. They will think together. So this learning is what generally we call it as active and cooperative learning. So the one who knows better will make them learn, the slow learner. So this also strategy that you can adapt. Give some topics and ask them to do on their own. I try and give one example of course outcome. A teacher. I take an example of computer science data structure, but it is true for every other subject that. So an intelligent teacher writes C1, comprehend different operations on various data structures like arrays, stack, queues, trees. Comprehend is understand. Understand is the second Bloom level. This another one he writes is apply the linear data structure and non-linear data structure for solving, something like that. Third one is analyze. The apply is the third Bloom level. Fourth, the CO3 that he writes is analyze the usage of basic data stage, linked list, etc. That is even the fourth Bloom level. Next, he is a very intelligent teacher. Conduct experiment to implement stack queues. In addition to the lab, you will make some assignment and then ask the student to conduct. So that is a beauty of learning. And he writes yet another outcome, CO5. Make effective and oral communication an advanced topic. He gives some topics and ask them to, thereby communication skill. You remember that out of the graduated bit, this is one way he wants to find out while teaching the data structure course. And lastly, he writes design solution for application using appropriate data structure. So he covers most of it. Understand, apply, analyze, design, including the communication skill and things like that. So I'll come back to this, because if you mere writing your course outcome, leave it there is no use. You need to assess them. So therefore, assessment tools are important. Wherever I go and ask people what is assessment and what is evaluation, most of the time I get an answer both are same. It's not quite true. Assessment is a measure of performance. So you have some tools, you measure them individually. But evaluation is interpretation of the assessment. Continuous evaluation, 50 marks, some 5 tools, 10 marks, add all of them. At the end, you will get this CGPA, this GPA, and this first class, second class. That is called evaluation. So therefore, assessment drives the student for learning. If there is no there is no assessment, student will not learn. So therefore, a good assessment tools that all of you do is very important. And these assessment tools should be informed to the student well ahead before the start of the teaching. Otherwise, at the end, if you tell, they are nowhere. So therefore, you should tell them. So when we are talking assessment, there are 2 important parameters called validity and reliability. So your assessment, if you do 10 times, you should match accurately. Each day that you assess the same answer book, if it gives different, there's no meaning. So validity is important. Even this answer book is given to some other faculty to grade, who also should give with a scheme. When you give a scheme, that is called validity. Reliability. Reliability, I'll give you in the next slide an example of GRE. What is reliable? Before that, let me introduce 3 terms for assessment. One is called diagnostic assessment. You should find out where they are weak in, where they are lagging. Then only you will be able to do the assessment later. he doesn't know anything. If you give an answer book question paper, he will get 0. So therefore, I have not written here. The first one is diagnostic assessment. Second one is formative. Formative is your continuous evaluation, test, quiz, assignment. That is, modest point. That is very important. What he says is there is no point in conducting the exam only 3 hours at the end and find out who is good or bad. That is called summative. So therefore, the new education policy also says, even in primary, first standard to 8th standard, only 3 exam. At the end of 3, at the end of 5, at the end, there is no final exam for first year, second year, fourth year, fourth standard, fifth standard. So that is what called formative assessment is going to come in future. So therefore, we all have to do a good assessment too. When you are doing summative, there are another 2 important parameters that you should keep in mind. One is difficulty level. Question paper difficulty level means I set a question paper, every student answers and get full marks is not a good question paper. Rather, on the other way, I give a question paper where nobody answers also is not. I must set a question paper where the average student should score 40, 50. The next level of the student get 50, 60, 70, 80. So that is the beauty of setting the question paper. That is where you bring in difficulty of question paper and complexity. One example is, is not non-engineering I can give. I give a question saying that what is the capital of Tamil Nadu? Everybody writes Chennai and got 1 out of 1. But a teacher wants to make it a little more complex. Same level, it's a remember level of blue. What it does is India has got 30 states. He gives a question, what are all the capitals of 30 states of India? So now, though remember, earlier they used to remember only 1 capital and got marks. Now they have to remember 30. This is how your question paper can be made more complex. So question bank concepts is coming now, as all of you know, because otherwise the student knows, predict what question that it is coming. Of course, it happens. It can happen 20, 30, but the whole question paper, if you predict, there is no examination. So therefore, now question bank creating is good for quiz or assignment or for test, and if not for the final, and use these assessment tools. There are so many tools that have. So I said GRE is reliable. Why? Because the GRE scores are valid for 5 years. GRE is conducted many times a year across the globe, but still what I score this year is valid for 5 years. That is because they use a concept called MSQ, multiple selection question. We are familiar with MCQ, multiple choice question. 4 questions, of which 1 is right. A teacher who is tired, he says A, B, C, D, none of the above. This is how we set the question paper. Then the probability of the student scoring out of 100 is 25%. So if you look at the GRE question paper, there are questions for which all the 4 answers are right. There are questions only 2 answers are right, 2 are wrong. 3 could be right, 1 is wrong. So this kind of a complexity they bring in. Therefore, this the gate scores, the gate examination, for instance, GRE, TOEFL, they are all a good exam, which I think we should make use of those quality in our question paper. I will try and give an examples of CI, continuous internal assessment. The same example of data structure, CO1 to CO6. So the Bloom level, if you look at it, CO1 is an understanding level, CO2, because I told you comprehend, it's analyze, apply. So this is a Bloom level. The tools that a teacher has chosen is 6. T1, test 1, T2, test 2 for another 15 marks, quiz 1 for 5 marks, quiz 2 for 5 marks, assignment 1 for 5 marks, assignment 5 for 5 marks. So if you know 50 marks, he divides and conducts these continuous evaluation. So what it does in the beginning, after a week or 2 weeks, he will conduct 1 test where CO1, CO2, CO3, he will ask 3 questions of 5 marks each, understanding level. CO1, understanding level of CO2, and CO3 is application. And later, after in 10th or 12th week, you will conduct the second test on CO4, CO5. That is 7 marks and 8 marks, totally 15. 7 marks, again, you will divide 2 for understanding and 2 for applying. In 8 marks on CO5, 2 for understanding and 6 for application. And you will, in the beginning, after a week, you will conduct one quiz. Quiz, you know, is only in the remembering level, CO1, CO2. The quiz will have 5 marks, 3 plus 2. And another quiz he conducts at the end on CO5, CO6, again on remembering Bloom level 2 plus 3. Somewhere in the middle, he gives one assignment for 5 marks of which on CO2, CO3, CO4. Remember, understand, and remember. And lastly, he will give one assignment on application for 5 marks. So you can see broadly he has covered everything in terms of test, quiz, and assignment all through the year. This is why, that's the reason why we call it as continuous internal examination, continuous evaluation. So this is the beauty of it. And autonomous institutions, they will also have a choice of doing their own exam with their own board of studies, board of etc. So again, same CO1, you can collect, first one 10 marks, second 10 marks, 20, 20, 20, 100 marks, you can divide like this or any other way that you think. So this is how the course outcome that you wrote need to be evaluated, whether you have achieved or not, attained or not. That is important. That's how you will be doing. So either to what I told is about the theory paper, practical, where you can use these assessment tools. But when you, let's say you take a project, if you say 100 marks, 25 for problem, 25 for thesis, 50 for final, 25 for presentation, has no meaning. The scheme has no meaning because the every will be bunched into same. So therefore, there is one more important assessment tool called rubrics. Rubrics is also as an assessment tool. So let's say a project, I take an example of a project. 10 futures are there, let's say 5 marks each, 50 marks. The concept behind the rubrics is when you put 5 marks for some future, you must tell student in advance when will they get 5, when will they get 4, when will they get 3, when will they get 2, when will they get 1. This is fairness is there and quality is there, and they are also motivated. So therefore, the evaluation scheme is different, rubrics is different. I'm sure that most of you must be using, and it's a tedious job in the beginning. At least first year, it takes a lot of time because projects are of different type. Some may be design, some may be simulation, some and so on. So therefore, you have to group the 60 students divided by 415 project into different, 3 blocks, and then write the rubrics, share with the student and do it, and you will enjoy. Later, it's a wonderful concept of evaluation. So this is what in terms, excellent, very good, good, fair, and poor, that makes a lot of difference. So I just give an example. Any project that you take, that there is a problem definition. There is a literature survey. Without doing literature, you don't know what to do. And after doing literature and gap analysis, the next thing, that obvious step in the project is methodology. You have to come out with a methodology. Then you have to come out with design, software or hardware. Having done, finally, you have to test it. After that, you have to present your work and you have to write your dissertation and you have to show your teamwork. As a 4 of you in a UG program, when you do, you can, in a PG project with one, the teamwork need not be okay. So you can rearrange the project evaluation rubrics. And your project can be an ethical or society, give some importance. Your project can be an environmental. If they are not there, you instead of 10, you can have 8. And so therefore, each one you have to have a rubric. Problem definition, 5 marks. You have to write a rubrics in 5 level. Excellent, very good, good, fair, and satisfied. So I again, data structure example I will give you. The first criteria is approach to the problem. Suppose, you have to write down the rubrics like this. Implement the most appropriate data structure with accurate and optimize. Good in all sense, student will get 5 out of 5. Suppose implements this, the algorithm that is implement right data structure with correct, but it is not optimized and not accurate, you give 4. So like this, you should be able to differentiate between the each mark that you give in the rubrics. For example, correctness of the algorithm, the right algorithm. If this algorithm works for all the cases, give 5 out of 5. If this algorithm works for 75% of the case, give 4 marks, and so on. Lastly, report writing also is very important. So you have to give some due importance. If format is right, content is right, everything is all right, good references are given, content is good, delivered, you can give 5 out of 5. So otherwise, if something his formatting is wrong, he has not done, he has copied, paste, whatever, you write down and then share with your student. This is the philosophy of rubric. So fairly, I try to cover you a global picture of outcome-based education, which says vision, mission, POs, PSOs, COs, and I told you about all graduate attributes, and I tried to give you some glimpse of the teaching strategies, including project-based, problem-based, experiential-based, and so on, and also try to give you some assessment, formative assessment techniques, and the summative assessment, and their validity, reliability, and complexity, difficulty level, and so on. These are the challenging for the student. So now the Bloom taxonomy, I told you in the cognitive is remember, understand, apply, analyze, and evaluate. So therefore, the assessment tool that you can use can be as follows. For remembering, as you know, you can give MCQ questions. True or false, matching, fill up the blank, very short answer, one line answer, flashcard, quiz. These are some of the techniques that you can adapt for assessment for remembering level of Bloom. For understanding, you have to go one step behind, simulation, animations, and tutorial in problem solving and all that, because the concepts, whether they have understood, unless you give some problem to be solved, you will not. Now in the apply level, in addition to MCQ, short answer, essay type, tutorial, simulation, game, case studies, so that unless you give some case studies, you will not be able to apply. And for analyzing, evaluating, creating, not all the subject that you teach will have this. So there you can use, in addition to MCQ, essay, project, portfolio, simulation, presentation, paper, virtual lab, case studies. So this is how the Bloom level gets complex. So therefore, when you should get satisfied. I taught first year, second year when I go, can I introduce one more, can I achieve one more aspect of this? This is how it is challenging for the teachers. So in the nutshell, I told you, vision is a broadest statement. Mission is broader. You can see the cones. POs are broad. PSOs are specific. And COs are more specific. So each course that you give, be it a theory, be it a lab, seminar, mini project, everything constitute a course. So this is what you should write down the course outcome, see at the end of the semester whether you have achieved or not, whether you have attained. Let us say, not that you can, the kind of students that you have, it's impossible to attain, even in IIT, to achieve, say, 100% for any teacher. So even if you achieve, let us say, put a target. I achieve about 60. Okay, you have taught, you have assessed, you have done your analysis, you have achieved 55. Then how do I go to 60? What kind of an improvement that I should be doing? You should list out and adapt them next time. Let us say you have achieved 60. Then how do I increase? The benchmark you increase to 65. So this is how the continuous outcome-based education takes place in the system. So I started with C.V. Raman. Now Einstein said, I quote, I never try to teach my students anything. I only try to create an environment where they can learn. This is all what you have to do in outcome-based education. Everything we should not teach in the class. Give them some assignment, give them some quiz, give them some extra things for them to learn. Is, let us say, 5 hours of teaching, you don't have to do unit 1. They can do and give an assignment on that, and so on. This is, create all these things in your. So therefore, teacher, according to William Watts, not Shivaprakash, He says there are 5 different types of teachers that you can see. One is called mediocre teacher. Second is good teacher. Third is perfect teacher. Fourth one is gifted teacher. Fifth one is modern teacher. So what he says is a mediocre teacher tells, he mug up in the morning, night, goes and vomit in the class. A good teacher explains. A perfect teacher demonstrates. That is the beauty. And gifted teachers inspires the student. Modern teachers facilitate. I want at the end of this short-term workshop, I want every one of you to belong to group number 4, group number 5, namely gifted teacher and modern teacher. This is a olden day thing. Gurukul, you must be remembering. There are no classrooms. They were teaching under the tree. Even now, Bihar, Nalanda University, where foreign students used to come. Of course, it's a very interesting slide where a teacher has got varieties of students, heterogeneous, which all of us will, all the students, heterogeneity is very high. You have a crow, to a monkey, to a penguin, to an elephant, and so on. So he has come out with assignment for all of them. The assignment is as follows. He says, you have to go and climb the tree. That is the assignment. But he's an intelligent teacher. He writes a rubrics. He says the rubric is as follows. If someone can go to the top of the tree, is an excellent, he gets 5 out of 5. If someone can go up to 75%, I'll give you 4. Very good. If you go to the middle, you'll get a 3. If you go 25%, you'll get 2. If you don't climb, you'll get 1. This is the rubrics, and the exercise starts. Everyone goes, and the crow quickly go to the top, and monkey is a big tree, could manage only 75%. Penguin with all difficulty goes to 50%. The elephant could not even attempt. He says the evaluation marks are as follows. Crow 5, monkey 4, penguin 3, elephant 1. So this is the beauty of rubrics. This I think we all have to adapt. We know the students are of different nature, fast learner, slow learner, but assessment cannot change. So the teacher says, the next assignment, Mr. Elephant, try to do well. Just you have failed, but this is not the end. You have to learn more and then compete. So whatever I told, there is a paradigm shift. Written exam is all going away slowly, becomes coursework. Tutor-led assessment. Tutor is a teacher. It's all become student-led assessment. Student-specific, personalized learning, personalized teaching, fast learner, slow learner, all these things, concepts are coming. Implicit is broad, is becoming explicit, very, very narrow. Competitions, broader again, are becoming collaborations. Product, very broad, is become process. Objectives, again broad, is becoming outcome. Content is about in a curriculum that we talk, unit 1. They're all broad, become competencies. Again, I am good in this. I am not a good mechanical engineer, but I am good in thermal. Again, in that, again, narrow. Competencies are very important. Course assessment are becoming modular assessment, and so on. So therefore, innovative teaching pedagogy is very, very important. And VELAMMAL Institute of Technology is doing a great job for all of you to learn 2 sessions a day with about 5 days or 6 days into 12. I'm sure we are all thankful to them. So I repeat what I said earlier, problem solving is extremely important. Open discussion during a tutorial. Tutorial for namesake, if it is there again, teaching the same class is no use. You have to take up some problem. Ask even student to go to the board. Acquaintance with the real-time application, case studies. A good autonomous institution can make elective subject 5 hours, 10 hours can be taught by industry person, so that he will bring some case studies. Cooperative learning, I told you, peer among the student, pair them, think them, that model also is very project-based learning. Every semester try to give some mini project. And these are all the things that student presentations are important, and this is only a few that I have given, but you can go on and keep adding. Okay, some of them are. So finally, the education should lead to something, should provide, according to me, 4 important things. One is knowledge, know-how, wisdom, character. What is knowledge? To understand the basic principle of formal and non-formal education, which anyway we do and get the knowledge. I told you in the beginning, knowledge alone will not take. You need skill, attitude, and so on. What are they? Know-how. To do things rightly. What is the right thing to do? That we should make our student to learn. We ourselves should learn. Wisdom. To set priority to work. You decide in the day, in the beginning, what are all things that I can do? Which one is more first one to do? Priority is extremely important. Character, to make trustworthy and respectable member of the society. The graduates, everybody should say, I'm a proud alumni of this and then I have alma mater. So therefore, how to reach, win this situation? I told you that this learning and whatever I told, shift is happening already. Shift has happened. Online and blended learning. And assessments are all online. So therefore, a flipped classroom, all of you are got familiar. Now I am going to introduce one more terminology called split classroom. Suppose the COVID doesn't go for a few more months. Student cannot come to the colleges. You have to split the class of 60 into 30. Ask 30 students to come on Monday, Wednesday, Friday. Another 30 can be asked to come on Tuesday, Thursday, and Saturday. 3 days online, 3 days offline. Blended, split, flip, any technology that you think you can. So you have to be innovative in pedagogy in future. So that is what for? We have to finally make our graduates to acquire this quality. Critical thinking. An engineer, if he doesn't think critically, is not an engineer. So how do we do? So therefore, our learning, our teaching pedagogy should give them that quality. Problem solving goes without saying. Reasoning, that is very important for an engineer. Creativity, extremely important. Project that we give. Imagination, innovation, entrepreneurship. Future is going to be all about entrepreneurship. Job, will not be there. Government job. You have to give job to others. Some of them can become, entrepreneur. He give jobs to others. Otherwise, you have to go and work in the private sector. So therefore, there are trends changing. I call it 9 trends. First trend is diverse time and diverse place. Diverse place. I am in Bangalore. You are there wherever you are. Some of you are in VIT, some of you are in the other part of the country, since you are attending from all over. So that is called diverse place. Diverse time means somebody can give a talk from USA morning, then we'll hear the talk in the evening. So that is called diverse time. So the future is going to be diverse time, diverse place, because of webinars, because of interaction, because of that, the virtual conference. Today, virtual conference are being held. Personalized learning, very important. Each one, we have to identify who is the fast learner, slow learner in our outcome-based education. Now, if you ask me, there is no failure in the learning. There is no failure. Student should not fail. He may score 40 marks, another man 80 marks. So learning may vary from person to person. I would think that, unless he gives an answer book without writing anything, you have to give 0. But otherwise, learning, is personalized learning is important. Choice, free choice. Most of the time, choice is there for the college or for the teachers. They list 4 and then say, because of the faculty, we are offering you only 1. That is not a choice. That is not CBCS, choice-based credit system. So you have to give choice. Therefore, management should come out with those, faculty which are available, because they can convert those into verticals. Project-based, without going, it says field experience, internship is definitely order of the day. Data interpretation, without that, you will not be an engineer. Exams will change. I have written, the exams have already changed completely. Student ownership, student has to own now. Mentoring will become more important, which I've told you in the beginning also. So therefore, in 21st learning paradigm, then there is a artificial intelligence, neuroscience, interdisciplinary, multidisciplinary, transdisciplinary. This is what new education policy is saying. This is one part of it. Then the second important part in the blue color, you can see soft skills. What is soft skill? Communication skill is one soft skill. Technical, managerial, teamwork, how to work in time management. Without time management, it is very difficult. So soft skill, communication, cooperation, dealing with diversity, language skill. It's not enough if you know only English. Now you may have, suppose I go to Germany, they insist that I should do. So one or two language, if you learn, that's also a good thing. And creativity is important. Dealing with uncertainty. Then innovation. Without, VIT, I is for innovation. T for teamwork. Innovation and teamwork will lead to values or victorious. That is why Vellore Institute of Technology is known for. Dealing with, finally lifelong learning. That is 25 hours. Information is available today. Earlier, we used to wait summer holidays and go only and attend the summer school or winter school. Only one opportunity in a year, 40 people. We are struggling to get an opportunity. So networking, interdependent now, personalized, adaptive, flexible. So these are all the scenario that you see in the paradigm of 21st century. So ACT, as you know, has got different platforms. Atal is one platform we call ACT Teaching Learning. Arpit, annual refresher program. So you can learn wherever you are. You can not today, all of you are learning sitting in your own place, listening to a person from other place. This is what, this NEET. NEET is again like a virtual lab. All the industries are coming forward. National Education Alliance for Technical Education, they are creating the labs, so that will be available to the student in this pandemic and even beyond. Swayam platforms are there. Swayam and Swayam Prabha is all for your theory course. Smart India hackathons are happening. India Singapore hackathon, Margadarshak. NAD is a depository. All the degrees are being also deposited because elsewhere people are cheating, with a bogus certificates. So virtual lab, I know that you must be using now. Partly www.VLab.coin. All IITs, College of Engineering, Pune, few more good institutions have come together and created the virtual lab for be it mechanical, civil, electrical, computer science. So if your curriculum matches with 6-7 experiment of that, please ask the student to learn virtually, even lab. And when they come back, they can perform. What one college doing in Bengaluru is they will make everybody to learn in 3 sessions. 12 weeks they were coming to learn 12 experiments. Now they packed in 3 weeks. That means in the same day they have to do three experiments or for 3 experiments or 4 experiments. That means you learn something from virtual world, prepare yourself, write your thing, then come back, and then what you do in 3 hours, now you have to do in 1 hour, take reading, and then go back home and do your exercise. So this is called blending, virtual versus real. So Google Classrooms and many tools are available today with Moodle, Turnitin, and whatever for your assessment. So therefore, 10 skills to be relevant to Industry 4.0, which I told in the beginning. Complex problem solving. Unless we make our student to solve this, employability is going to be a problem. Critical thinking, creativity, people management, networking is important. Coordinating with others, that is also important. Emotional intelligence, judgment and decision making, service orientation. You should be always, we say what institute is giving, what is that we are giving to institute, to the college, and negotiation they should learn, and cognitive flexibility. We are there 30-40 years in the same institution, which is not going to be future. The graduates will be there in 3 to 5 years in one agency or one company and then move to the other. So therefore, flexibility, how to learn cognitive, because flexibility, they have to learn and then move on quickly, learn quickly, and go to the other job. So last part of my talk is about technology. IT plus IT equal to IT. Mathematically, all of you know it is not correct. But what I meant is information technology yesterday plus information technology today equal to information technology tomorrow. So therefore, we had in 2000 IT, now biotechnology. Today COVID vaccines are there. So geotechnology. So today's research is tomorrow's technology. Country like ours, primarily we depend on agriculture. Health sector, we are still lagging. Insulins or drug delivery. Infrastructure, of course, we far away. Climate change. So these are the problems in which, these are the areas in which you can give problem to the student for their project, which will have more impact. And job opportunities also will go up, to them. So just to name a few, which all of you are very, very familiar by now, 100 times you must have gone through this. Artificial intelligence going to play a major role. So artificial intelligence, I as a personal view is it cannot make a BTech project. It is a tool. It can be used by across. Now the area that I am going to show you, they are all no boundaries. See, in another 5-10 years, there may not be civil, mechanical, electrical, computer, and this all, like nanoscience. You need biologists, you need physicists, you need engineers, electronics engineers, mechanical engineer, neuroscience, earth science, for instance. You need civil, you need a physicist, you need geologist, and so on. So IoT, Internet of Things, they're all tools. Robotics, AI and robo will take, at least in medicine and education in the next 10-15 years. Cyber security, data science, quantum computing, which is coming up. 3D printing is what we call it as additive manufacturing, product design, and so on. Blockchain, augmented reality, and whatever. So therefore, India is a country where we, our Dr. Kalam had a dream of doing India with Pura, P-U-R-A. What is Pura? Providing urban facility to rural area. If we can do no migration, nobody will come to cities. Good hospital, good school, everything if it is given, good roads, they will not come. So therefore, I request as many projects as possible to do in this area, which I call it as Astra, A-S-T-R-A. What is Astra? Application of science and technology to rural area. Take some rural area problem, give them, rather than, just doing some small simulation and then going. So artificial intelligence in education, personalized teaching, AI is used today. AI is used for proctor, when conducting exam, whether it's copying or not, you can find out through using AI. Tools are there. AI is also used today in medicine. For diagnosis they are using, and also some of the surgeries are being used by robotics, AI and robo, helping the doctors. Blockchain is, of course, is nothing in engineering and management, where e-commerce, everything is E. The transaction taking place, that they all through E. Genetic testing, of course, is not much importance to this unless you have biology or biotechnology, where DNA, RNA, genomics you can create. Especially all engineering college can take up some project in 3D printing. Very important. A lot of product design can be done through this. And AR, VR. 2 months ago, there was an convocation of IIT Madras. They have created, using AR and VR, a guest was giving a medal to the student, a robot moving with this. So they're all possible. A real experiment can be conducted in the virtual world by using AR, VR. Another area which is going to make an impact is autonomous vehicle. Of course, driverless vehicle in India may be still difficult because of the traffic congestions, but electric vehicle is going to come. In 5 years' time, you'll be seeing buses, trucks, cars with electric. No more petrol bunks, maybe after 10 years. You have only charging station across all over the road. So that is an area where people can work on batteries and things like that. Hyperloop. 2 months ago, I saw one article that Japan underground, they could go 500 kilometers in 10 minutes. Even aircraft cannot go. Aircraft can go only 900, 950 kilometers per hour. So in Pune also they tried out. Europe it is coming up. So people want to go as quick as possible. Smart city is going to play a major role for all of us. A lot of opportunity. How can we create a smart city without good road, good building, without good communication? So therefore, lot of opportunity for civil, mechanical, electrical, computer, IT, every walks of engineering will have huge potential in next 5-10 years, because India has got a program for next 10, 15 years to make large number of the cities and also towns and districts. We have 750 districts. If you can make 750 smart cities in country, that will have. So future India is, earlier we had made in India, that is product with label made in India locally, but now it is make in India. What is the difference? New foreign investment, job is for our people, profit is us, part of the profit we have to give to them. So that requires digital India, digital infrastructures, governance, and also digital empowerment to citizens. Today we don't know how to live without a mobile. So we all got used to it, whether we like it or not, things are going to change. So possibly I stop here. To achieve the new education policy in the country, outcome-based education is important. So therefore, if meaningful new education policy has to be implemented, outcome-based education at every institution in the country is important. Because I told you, affiliation system will go in 10, 15 years. Every one institution with 3,000 students will be able to give teaching university status, and the universities, Anna University, JNTU, VT, they all become research universities. IITs will become multi-educational research, where IIT cannot survive only with engineering science. They need to bring in medicine, they need to bring other walks of life, which they have already started doing. So therefore, to achieve equality, we need to work together, collaborate with each other, tolerate the differences. Academicians do have differences. Please tolerate, respect the diverse view, take all the views together, because none of us is as smart as all of us. So I stop here. I thank the management of VIT, Dr. The principal, Dr. Kaliyappan, third innings that he is doing today, November, December, and now, and Dr. Basin, and all my dear colleagues there at VIT, and more importantly, all the people who are listening to me this afternoon. Listening after 2:30, 2 o'clock is not an easy thing. I hope that I could give some bird's eye view of the outcome-based education, basically about learning and about assessment tool. And I'm sure that in the next 5 days, you will learn small issues of this in greater detail. Thank you very much. Over to Dr. Kaliyappan.
Thank you, sir.